Hello, my little mathematicians. Today we're going to explore multiplying decimals with area boxes, and then hopefully by the end you'll see why multiplying decimals works out the way it does and why we get certain answers that we do. Okay, so first off, let's go ahead and take a look at this area box down at the bottom. Okay, we're going to use this when answering the questions. So if you could see, like, this is one square unit, right? So it's 1 by 1, length times width. 1 times 1 is 1 square unit. Well, that means that each little individual box is what measurement? Well, if I look at the length right here, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across, right? Okay, so if that's 10 across and you want to know what the area of one little small box is, you would have to find what this length is and what this width is. Well, this is 1 out of 10 across, so we'll say 1/10 or 0.1, same thing. And then the width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down, and it's only one of those 10, so 1/10 for the width as well, or 0.1, same thing, 1/10 is 0.1. So then the area of one small box would be 1/10 times 1/10, right? Length times width. Well, 1/10 times 1/10 is 1/100th, and 1/100th is 0.01. Okay. Why does it work out that way? Well, if you look at it, you're finding the area, and this little box is 1 out of how many total boxes? Well, there's 100 total boxes, and this is only 1 out of those total 100. So I would say that one small box is 1/100th, or you could say, or 1 out of 100 tiny identical boxes. Okay. Or also we could have taken the math part up here. 1/10 times 1/10 is 1/100th, because length times width, this is 1/10, this is 1/10. So in this new model, what's the length of one side? Well, we just established that. Okay, the length is 1/10, or 0.1. And then the width, we established that too, that the width is equal to 1/10 as well. Okay. So then what are the dimensions of a rectangle that is 3 small squares by 5 small squares? So 3 small, let's do it over here. Okay, 1, 2, 3. So that's 0.1, 0.1, another 0.1. So that's 0.3. Okay. By, we said 5. So 1, 2, 3, 4, 5. So 0.1, another 0.1, another 0.1, another 0.1, another 0.1, for a total of 0.5. Okay. So the dimensions of this would be 0.3 by 0.5. And it would look like, if I were to complete the rectangle, here is the rectangle that would look like. So you would get 15 total boxes, or 15 out of 100, which is 0.15. Okay, use a rectangle to the right to show the dimensions of a rectangle. That would be 0.6 by 0.2. Okay, so let's measure out 0.6. I have space down here. 1, 2, 3, 4, 5, 6. Okay, by, they said 0.2. Okay, so if I were to write that out as a multiplicative sentence, you have 0.6 times 0.2. Well, what does that equal? Well, if I look in here and I complete the rectangle, that is 12 out of 100 boxes. So that's 0.12. So 0.2 times 0.6 must equal 0.12. Okay, that's the mathematical sentence for that one. Notice that 0.2 times 0.6, that's the same thing as if I did 6 times 2 is 12. The only thing is there's one number after the decimal, another number after the decimal, so I had 2 total numbers after the decimal. Same thing with this one. We said that the answer was going to be 15 hundredths or 0.15. 3 times 5 is 15, one number after the decimal, another number after the decimal, and look at that, 2 numbers after the decimal. So it kind of looks like if you multiply decimals, it's the same thing as if you were multiplying normal numbers. It's just then you have to take the decimal part into consideration. You count how many numbers are after the decimal here, how many numbers are after the decimal here, and that's the total number of numbers after the decimal in your answer. Let's see if that continues to follow. Okay, so for this side, it says we still have the same area model. So let's go ahead and try to represent this 0.3. So that would be 3 across. Okay, and 0.3 is like 3/10 by 0.7. Okay, so right there is 0.7. And 0.7 is like 7/10. Okay, what would that rectangle look like? Well, the answer would be 3 times 7, which is 21 total boxes. Okay, so let's see how 21 comes into play with this. Well, 3/10 times 7/10, you get 21 out of 100, which makes sense because we said that this was 21 boxes out of the total 100 boxes. And 21 hundredths is 0.21. Well, if I look at just normal multiplication, 7 times 3 is 21. 7 times 0 is 0, plus 2 is 2. And then I need a 0 placement marker because I'm moving on to the next number. And it's 0 times 3 and 0 times 0. Okay, so there we go. And you have 1, 2. Look at, there was one number after the decimal there, one number after the decimal there, for a total of 2 numbers after the decimal in my answer. And that's what I said I should have gotten, was 0.21. This is why when you multiply with decimals, it works out the way it does, because each decimal is representing like 0.1 of a square. Okay, let's go ahead and try this one. So you have 0.2 or 2/10 by 1, 2, 3, 4, 5, 6. Okay, 0.6 or 6/10. So if you multiply that, any predictions on what you would get? What do you think 2/10 times 6/10 would be? It's going to be across as 12 on bottom hundredths. And 12 100ths is the same thing as 0.12, which makes sense because if I complete this rectangle, I have 12 total boxes inside the rectangle out of 100 total boxes. So 12 100. Okay. If I were to just do the normal logarithm and multiply it out, 6 times 2 is 12, carry the 1. 6 times 0 is 0, plus 1 is 1. And then 0 placement holder, 0 times 2 is 0, 0 times 0 is also 0. Add down, you get 2, 1, 0. One number after the decimal there, one number after the decimal there, for a total of 2 numbers after the decimal, which equals 0.12, which is what we said it would be, 12 100ths, right? And that's why when you multiply decimals, it works out the way it does. All right, congratulations, my little mathematicians. Hopefully this helped give you a little visualization. From here on out, we're probably just going to be doing the logarithm. But if it helps you, you can draw it out to see why it works out the way it does.